So in this video, I want to describe what are called exact equations. And exact equations are a type of differential equation that you get that arises from essentially the chain rule in Calc 3. So what I want to do is I want to start with, and we're going to work our way backwards to see how these are solved. But we're going to start with some equation in two variables, x and y. We're thinking of x as the independent variable, y as the dependent variable as usual. So y is a function of x. And we're thinking about these functions of two variables equaling a constant. Okay, and so it turns out, since we're working backwards, that's what all of our solutions are going to look like eventually. So just keep that in the back of your mind. What we're going to do is I'm going to differentiate both sides with respect to x. And on the left side, we need the multidimensional chain rule. And so what it turns out we get is the derivative of the function f with respect to x times dx, which we'll just leave alone, plus the derivative of f with respect to y times dy dx. And of course, the derivative of any constant is 0. And then one thing that's customary is, even though I keep saying dy dx is not a fraction, it behaves like a fraction. So one thing that's customary is to rewrite this, and to rewrite this equation as f sub x dx plus f sub y dy equals 0. And again, remember that this is my notation for the partial with respect to x, the partial of f with respect to x, plus the partial of f with respect to y. So these are the types of equations that we're going to look at now. And not all of them are going to be of this form. So what we need to do is we need to figure out, is there a criteria for categorizing which functions have a solution like this, f of x, y equals c? And so it turns out that this criteria that we're looking for is called the criteria for exactness, because the solutions that are of this form we're going to call exact equations. And it turns out what we're going to do is we're going to use a fact from Calc 2 that if f is nice, and by nice I mean that f has continuous second partial derivatives, but whatever, if f is nice, then the second partial derivatives commute, meaning that if you take the derivative of x first and then y, that's the same as taking the derivative of y first and then x. And so this is a fact that we use in Calc 2 frequently when you do things like the d-test and you have to compute second partial derivatives. This is the type of thing that gets used all the time. So if f is nice enough, which most of the functions that we're going to talk about in this class are nice enough, then the second partial derivatives commute, meaning that the order doesn't matter. So we're going to use that to our advantage. And really what we're going to do is we're going to study equations that are some function m, and I'm going to write it like this: m of xy dx plus n of xy dy. So we're going to have functions of x and y for m and n. But really, just for convenience, I'm going to forget that m and n are functions of x and y and just write it like this. Okay, maybe what I mean is we'll keep it in mind that m and n are functions of x and y, but not write it down. And so if we want to check whether or not there's a solution that's exact, what we're going to do is we're going to try and figure out, do these second partials commute? And what I mean by that is that we're going to take this thing in front of the dx, which is f sub x, and we're going to differentiate that with respect to y. And so it turns out that this equation star is exact if the partial of m with respect to y is equal to the partial of n with respect to x. And if it's exact, the way that we can go about finding the formula is by anti-differentiating a couple times and comparing our answers. So we'll actually go through that when we go through some examples, but this is what we mean by the criteria for exactness. So if it turns out that these two partials are equal, then from that we can conclude that this is an exact equation, and therefore we're going to get some sort of solution of the form f of x equals y. I'm sorry, f of xy equals c. We just have to figure out what is that function of x and y. Okay, and so we'll do that as we go through and do some examples.